Hi, in this video, I will demonstrate how we can use LLM's abilities in an agentic way to kind of interact with Git repository. So what I will do what I will do ultimately is create like an coding agent that will interact with Git repositories, read issues, make code changes, commit, create merge requests and things like that. Now it will be like a basic implementation and it can be extended further to do even more complex tasks. And I will also demonstrate how to um, implement and run this agent in a more or less autonomous way. So it will require minimum intervention. Um, Now, before we go deep into the code and how to use it, just a little bit about the setup and the prerequisites that this agent requires. So this specific agent will interact with GitLab, which is a software platform to manage code and software projects. So what I did is I did create a sample project for doing my testing at GitLab, and I created two accounts, one for me and one for the agent. And then I gave access to the project. I gave the agent access to the project. So if I go to member, I should be able to see all the members that this project has. So here you can see there are like two users. So it will at least require developer role for it to work. So what it will do is when the idea is if I go to a list of, so what I did is I created some sample issues, right? So these are very doing basic stuff. For example, if I go to the factorial function issue, we'll say create a Python function that can calculate the factorial of a number. This particular issue is asking to write a Python function that returns true if the input string is palindrome. So the idea is if you assign this issue to a agent, it will automatically pick it up, right? And it will do the necessary code changes and then commit and create a merge request and then assign it for review. So that's kind of what we are going towards. Now let's go back to the notebook. Now, just to give you a little bit more information about the prerequisites, so some of the things I already talked about, we do need GitLab, and it needs to interact with using GitLab API. So in order to do that, I created a access token directly from GitLab, right, for the agent to use. It also needs Git installed locally because for this demo, the agent is expecting the repository to exist locally. Now we can modify the code so that the agent can clone its own repository, but for it to work, it will need Git installed. So that's why Git is a requirement for this to work because it will allow the agent to clone, make commits locally, and then again eventually push. In order to interact with Git, we have the Python interface library that we are using. It's the Git Python library. And in order to do the actual code generation, right, we are using the DeepSeek Coder model, right, that I'm deploying it locally using Olama. So you can easily go to Olama document and download Olama and then use this Olama pull DeepSeek Coder to get the model. Now I do have a VRAM of 12 gigabyte, so I would recommend to have at least 8 to 12 for kind of a smoother and fast response from the agent. In order to manage the prompts, I'm using LangChain. So when we go to the code, you'll see that it's using LangChain to chain the prompt to its prompt template. It will use that to kind of invoke DeepSeek to generate the code. I'm also using Black because sometimes what happens is when the AI model generates code, it's not well formatted, right? So I'm using the Black library, Python library, to kind of format the code. So these are kind of the basic prerequisite and setup that we need. So we need Git installed. You have to have some sort of GitLab target repository that we are working with, that the agent will be working with. Okay, so now let's go and kind of go through the code and how it does what it does. So if I, okay, so I'm loading, so what it's doing is I'm loading the token here. And here in this particular demo, I am only working with one project, but this can be easily extended to multiple projects, right? So here I'm only targeting one project. That's why I specified the ID. You have the API URL for the GitLab, and this is the path where I have cloned, or will be cloned, or have cloned the repository of the project, right? So the agent, then we have the agent username, right? So this is the username that I created for the agent to work with. And it also has a review username that's kind of optional. So if what it will do is once it makes the changes, it will assign me as a reviewer for those changes. So let's go to how it's kind of working. So we have these basic two functions which will kind of allow the agent to make get and post requests to the GitLab API. So that's kind of as straightforward as it gets. In terms of get operations, this is the first useful function that the agent is using. And what it does is basically makes a request to the GitLab API to get all the open issues in the project that's assigned to it. So it's anything that's assigned to the agent is trying to fetch those issues. So for example, if I run this portion of the code, it should return nothing because nothing is assigned to the agent right now. And if I go back to the issue list, right, and let's try to assign a couple issues to the agent. So what I will do is I will assign this to the coding agent, and I will also assign this to the coding agent. So now two issues have been assigned to the agent. And if I go back to my demo, and if I run this again, you will see that it's picking up those two issues. So this is how kind of the agent finds the issues that are assigned to it. Now, then there are some helpful functions that it will use to kind of interact with the repository, right? So this particular function will make a branch and do a commit. And there's another function that kind of makes the merge request. Now let's go back to the kind of the core of the agent, which is how it generates the code. Now I'll demonstrate in a second how it's kind of getting what task it needs to do. But if I pass a task to this function, the task is basically in this case is basically the issue description, the details. So if I go back to an issue, whatever the description here, that's kind of what it's passing to this function. So it's trying to use that as the instruction for DeepSeek to generate the code. But here it's also using a template, right? So it's using a template that I will be passing off to a LangChain. Now the reason it's using a template because we don't need all the explanation of the code. We just need just the code that it generates. So it's just giving some instruction of how it can generate the code without any explanations or comments. So that becomes a template, and then we're chaining the template with the task, which is in this case the issue description, and then we are invoking the model using OLAMA to get a code output. And then there are a couple functions that what it does is it takes the code output and it kind of formats it, like it takes away some markdown syntax if it's there, stripping comments or excessive comments or things like that, and then it also formats the code using Black library. So that's that. Now there's also an optional function that it uses to kind of get a target file name. So for example, if the issue mentions a file name where the code just needs to be in, it will try to pick that up and it will use that. Otherwise, it will add the new code to this default library. Now these parsing could be improved much more, kind of to do even more complex maneuvering of changes. Now this is the kind of the flow now. So what we'll do is this function, it will process. I will show you how to run this continuously, but if I just want to run the agent once, right? So it will go and grab the issues that are assigned to it, and then it will do the necessary tasks, create commits, and then push. So in order to do that, this is the function that gets used. So what it's doing in this inside the function, it's going and picking up the repo using the repo function. It's using the repo path that's defined at the top of the code. It will get the repo and it will use that first function that I showed. It will get all the open issues assigned to the agent, and then we'll loop through each issue that's assigned to it. So what's happening is it's trying to get the issue description, right? Issue description that's attached to the issue, and then it will pass the description of the issue to that function that invokes DeepSeek to create, to generate the code. So this then returns the raw output. So once it returns the raw output, it will then use those two helper functions to kind of extract and format the code, the pure code. So what it returns at the end is the formatted code that we need for pushing to the repository, back to the repository. Then it will use that optional function that extracts the target file name. So in this case, the description did not indicate any specific file name, so it will put the code into the util.py file, right? So that would become the target file. And then we are basically naming a branch now that could be customized to whatever we want. Here we are just customizing it to the branch name to be just the issue ID with some suffix and prefix, and then you also have it. You can pass a commit message now, and then we use this create branch and commit function to kind of take this code, put it in a new file, and then push that file back to a branch, right, and commit it and push it. And then after that, we do open up a merge request and then assign it to a user, in this case me, as to review it. And then it will just print that it has processed, and it will display the merge request URL, and then it will also remember which issues that it has handled so far, right? So that's kind of the flow of how the agent is kind of picking up the issues, making changes, and then pushing it back, and then repeating for each issue that's assigned to it. And it will go through all the issues assigned to it, and then it will stop. So that's what I mean by when we use the agent once. Okay, so if I run this, just to demonstrate what happens, if I run this right now, it will go pick up those two issues and make the necessary changes, and then it will push them, right? So let's try to run this and see what happens. Again, so we do have two issues signed so far, and then let's run this function. Okay. I forgot to initialize that. Let's try again. Okay. So here you can see it's processing issue number one. I did not run all the functions. So let's run. Okay. It should load all the functions. So let's try. So you can see it kind of made the first commit for the first issue, and it generated this URL, and then it went and processed the second issue. Now if I go back to this MR, you'll see the change that it made. So it created this branch and it assigned me as the reviewer, and if we look at the changes, you'll see that's kind of the factorial function that created util.py automatically. Now, if I go to the second one, if I click on this one, you will see it should have made, again, another branch, assign me as the reviewer. And then if I go back to the change, you'll see that this simple change, simple function was created by the agent. And here I'm kind of showing the screenshot of some of the changes that it made. So now, so the another use case is we have to sometimes run the agents continuously, right? So then this function helps to do that, where we are polling in background, which means it will automatically run in the background, and anytime a issue is assigned to it, it will pick up and do its thing. It will generate the code, and then it will go back to polling for issues. So if I run this, so this is the function that does that, and I'm using threading to run it in the background. So we'll start threading. So you'll see it will keep saying polling for issues. So right now there is nothing to do because the two issues that were assigned to it was already handled. Now I'm using an interval of 15 seconds, but it could be, probably should be around 60 seconds for the demo. I'm just using 15-second interval. So see, it's polling again. It didn't find anything. So what I will do is I will go back to the issues and I will assign a new one. So I have this third issue that just creates a function that reverses this string, and I will assign it to the coding agent. So as soon as you do that, it will pick it up the next time it polls. So you'll see it will polling again, and it will eventually find the issue. Okay, so here it found issue number 3, and now it's processing it. It's generating the code, and it will do the same thing that it did with the other two issues. So it created this third MR. If I go back to it, you will see it did the same thing. It created a branch, assigned me for review, and it has the function in it, in the changes. And then it will go back to polling again. So this is how you can run the agent continuously in your machine, and when you don't want to stop it, I can just set this flag to true, and it will stop polling next. Oh, sorry, polling stopped. So that's kind of the agent is working with this basic implementation. Now you can also obviously extend it a lot. We can improve things like give it a memory, so it will remember what it did, what kind of changes it did. So it will be repo aware. We can use a RAG for that. We can also extend it so it can do back and forth conversations with the reviewer in the using the GitLab API, and generate automatic tests, add documentation, and things like that. So it could be extended a lot, but that's kind of the basic idea, where we give the agent some API access, and then it uses that to and uses a LLM to kind of generate, parse code, and then do certain operations with minimum intervention as possible. So the idea is to kind of help with repetitive tasks, trivial coding tasks, that should save time for developers as they're working with bigger projects. So that's kind of the project. Thank you for listening. Bye bye.